even, whichever may be the name, are independent in the sample. Each observation is represented as either success or failure. Success means outcome is favoring you.
Increase the voice on this thing here.
Failure means outcome of the experiment is not favoring you. For example, you are going to a shop to buy a shirt of your choice. You searched it, you got. That means you got success. In the shop it is not available means you got failure. Because the experiment is random, there is always a probability for success and there is a probability for failure, P and 1 minus P, always. X is the number of successes in the sample. And probability evaluation is given by this function. Out of sample of n, X are successes. For that, P raised to X is the probability. Remaining n minus X are failures. For that, the probability will be 1 minus P raised to n minus X is a model to evaluate probability of X in the sample. To evaluate probability in the sample. This is called binomial distribution. Bi stand for 2, either success or failure. Nominal stand for sample n. So, binomial probability model. And these all characteristic I can explain by following example. Let us see question number 1. State probability of 0, 1 or 2 successes on 6 independent trials where probability of success is 0.3. Say for example, 6 customers, that is n. Success means prefer coffee. Failure, not prefer coffee. So P is probability that a customer prefer coffee. And X is number of customers preferring coffee in the sample. This is the meaning. And your job is to find probability X is equal to 0, probability X is equal to 1, probability X is equal to 2. This is what the meaning of the question. Six customers represent the sample, but I don't know among 6 how many prefer coffee. %30 chance a random customer prefer coffee. 70% chance he is not preferring coffee. Prior information. Then evaluate probability of 0, 1, 2 in the sample. In our R package, we are going to use these many syntax today. D, binom, P, binom, Q, binom, R, binom. Function is binom. So when I work today for answering the question, any doubt?
Sir, I have a doubt. Sir, in this question, the number of trials could be 7 now because 0 is also added. 0, 1, 2, 3, 4, 5 and 6.
You didn't understand the question at all.
I'm saying the number of trials.
That is 6. What is your name? Your name?
Yes, sir.
Your name?
Cherry, sir.
X is number of customers preferring coffee in the sample.
Check whose name is Cherry.
Yeah.
So X is equal to 0 if nobody prefer.
You need to sound very
yes. So that is one
Cherry sound
case.
How it is 1? That is value for X in the sample.
Okay.
And maximum
Sir?
all of them prefer the coffee. That is 6.
Sir? Hello, sir?
Yes.
Yeah, can you scroll up a bit? I'm writing down the question.
Module already we have sent to you.
Sir, I haven't received.
No, you have to carry with you. State the probability of.
We have a problem in the first line. State of probability 0, 1 or 2 on 6 independent trials. Wouldn't it be 7 trials?
Probability of in Salarik the semester is very low. Very shakal will line.
This is too much.
Sorry, sir, I'm making you do this again, but I just couldn't understand. I'm sorry.
I'm repeating now. I'm repeating. You have to answer my question. How many customers are coming in the shop?
6.
That is sample size.
Okay.
What I am going to study on them?
What if they prefer coffee or other?
So if all of them are not preferring coffee, so how many prefer coffee?
0.
That is the variable. All of them prefer coffee. How many prefer?
6.
So what are the possible value for customers prefer coffee in the sample?
0, 1, 2, 3, 4, 5, and 6.
This is not trial. This is value for your characteristic.
Okay.
This is value of your characteristic event. Clear now?
Yes, sir.
So asking, evaluate the probability for 0, evaluate the probability for 1, evaluate the probability of 2 in the sample. मैंने लिखा है, I have written. So to answer the probability of your characteristic in the sample, red color, all these are functions we are going to use. So let me start with R. Yes. I'm using binomial distribution. Question number 1. X takes the value 0, 1, 2, 3, 4, 5, 6 possible in the sample. So the syntax for probability distribution for every values is D binom. D binom gives individual probability in the sample. I denote PBD. P stands for probability. BD stands for binomial distribution. Is my notation. Any notation you can use. D binom, my characteristic, sample size, and probability of success. That is the syntax. So let me see the answer. I got it. I got very first probability for 0 success. Second probability is for success number 1. 2 successes 3 successes, 4 successes, 5 successes, and 6 successes. And we want the probability for 0, 1, and 2. So P0 D binom 0, 6.3. 1 P1 D binom 1, 6.3. P2 2 successes D binom 2, 6.3. I have my probabilities. This is question number 1. This is question number 1. My sample is of 6. And number of customers have success 0, 1, 2, 3, 4, 5, 6. Evaluate the probability. So D binom. I got. And we want the probability for 0, 1, 2. That also I got by putting the values. These probabilities I can plot on a graph. Probabilities can be plotted on a graph. In correlation regression, we have studied the graph. Suppose I plot the probability on y-axis and x value on x-axis. Plot probability curly x and the type in quotation O. O stands for marking on the graph. Probability should be marked. Not 0, it is O. Small o. Let us see the graph if I get. If I draw the vertical line for each x value, intersect on the graph is the probability. Intercept on the graph is the probability. Naveed Rai.
Yes, sir.
Do you follow this probability computation and the graph?
Yes, sir.
Did you get the graph?
Yes, sir. Yes, sir.
Neeldhar,
Yes, sir.
do you get the understanding of computation as well as graph?
Sir, computation, yes, but in the graph, I'm a little confused when you have written type equal to
Quotation and
yes.
small o.
Yes, that I understand, sir. But otherwise, computations are no issues until P0, P1, P2, no issues understanding, sir.
Okay. Rachit Tyagi.
Yes, sir.
So D binom represent what? What it gives?
Sir, it is the binomial distribution of that particular N and P.
Akshat Sen. Akshat Sen.
Yes, sir.
Do you follow the today's computation?
Yes, sir. So could you again, it's the same as Neil only. I didn't understand the type equal to O in a quotation.
That represent the marking on the graph. Did you get the graph?
Oh, yes, sir. I got the graph.
Marking on the line, circle. Can you see circle on the graph?
Yes, sir.
That is called probability. So, this is question number 1. Suppose I want to show, I'm going slow, I want to show the probability for 0 on the graph. I say AB line, vertically equal to 0, comma, a color, I represent blue. Let us see. Can you see blue line?
Yes, sir.
Similarly,
Yes, sir.
I want to show the probability for 1. And the color say green. Similarly, I want to show the probability on the graph. All the red lines are probability for 3, 4, 5, 6. Our required probabilities are blue, green, yellow. Rahul Ghosh.
Yes,
Well
sir.
clear?
Yes, sir. Absolutely.
Yes.
Sir, I have a question. What if you want to draw a
Yes.
horizontal line? What will, I mean, like, are we supposed to change the V into an H?
Yes, but here H is not possible because my values are x-axis.
Okay. Sure.
My values are x-axis and the probabilities are for x. So I always go for vertical line.
Sir,
Okay.
I mean, his question makes sense. Like, let's say his question is, what events have a probability more than 25%? So if we put a horizontal line at 0.25, then we can clearly see what is above that. So probability of having one or two successes, then I mean,
Wait
Ali's
now.
question makes sense.
Kneel there. Just wait.
Yes, sir.
Just wait. Just wait. Ali Sagar,
Yes, sir.
clear now?
So, okay,
For
sir.
the question,
I'll wait. So maybe maybe we'll cover it in the future.
vertical line stand for x values.
Mhm.
That is what we were doing in question number 1. We have not done more. Just wait and see the change.
Okay, sir.
So, yes. Okay. So this is question number 1. Now let us go see how the question 2. Probability of producing a perfect drill for oil is 0.95. A perfect drill. If 5 drills are chosen, what is the probability that 3 are perfect, 4 are perfect, 3 or more are perfect? N is 5 drills. Small p will be 0.95. X is number of drills they are perfect among 5.
Sir, it would be 5C3, 0.95 to the power 3 and 0.05 to the power 2.
Is formula. Correct. You are correct. This is formula. And we are computing it by R. We are computing it by R. Let us see what we get. Question number 2. I denote x1 because in first question I have used x. Not to confuse, I am using another notation. So number of perfect drills in the sample will be 0, 1, 2, 3, 4 or 5. The probability distribution of the second question will be D binom x1 5.95. I got the individual probability now. Zero, 1, 2, 3, 4, 5. Zero, 1, 2, 3, 4, 5. But we want probability for 3, 4, so D binom 3, 5.95. D binom 4, 5.95. They are individual probabilities. These are the answers. But the last question will be cumulative probability because 3, 4, 5 and add. So whenever you have cumulative probability, you are using P binom, not D. And P binom will give you cumulative probability from minimum to the cutoff point. Therefore, the last answer will be 1 minus P binom up to 2. Because total probability always 1, that you have seen in the last class. So 1 minus probability up to 0, 1, 2 will give you for 3, 4, 5.
हेलो हाँ जी ओके या सर
This is the answer.
Okay. Okay. Yeah, my address, you can note it down.
This is
flat
asked.
number 10. I'll send it to you via SMS, kya?
Probability
I'll
that
SMS you right now.
either 3, 4, 5 are giving perfect drill in the sample is a cumulative probability. The other two are exact probability. So let me plot the probabilities. Now everybody knows. Plot the probability distribution and the vertical line on the graph. So smaller the x value, smaller the probability. Higher the x value, higher will be the probability. So the graph will be having a peak to the right. But I found cumulative probability. What is cumulative probability? Cumulative probabilities are probabilities starting from 0, 1, 2. Look, 0 probability, 0 plus 1 probability, 0 plus 1 plus 2 third probability, 0 plus 1 plus 2 plus 3 next probability, 0 plus 1 plus 2 plus 3 plus 4 is the probability, and all that is 1. Even here also we can plot the graph. So if I plot the cumulative probability graph, it will show something different. Almost similar. Almost similar. Even you can compute the probability in a different form. Say you want the probability from 3, 4 and 5. So there is an alternate procedure. The range of values are 3, 4, 5. Find the addition, sum of D binom 3 to 5, 5.95. And AB line, V and the range we have here PC1. So AB line, vertical, range, then color equal to red. Why I am not getting here?
Sir, just delete the space between range and color.
Ah, yes. It is not acceptable. Yes. So here the probability will be shown only for not ring. Okay. I understood. Yes. This is what the answer in the graph. Addition of 3, addition of 4, and addition of 5. So two functions you have learned, D binom, P binom.
So,
Two functions in R you have learned.
sir,
Yes.
so can you please explain this range part?
The last question was evaluate the probability for more than 3, greater than or equal to 3. So 3, 4, 5
Sir, I
is
have a
the
question.
3, 4, 5 is the range for evaluating probability. So I denote it by range 3 to 5. Compute the probability for that. Plot it. Because D binom for 3, D binom for 4, D binom for 5, and add up. See, now I have written sum D binom 3 colon 5, 0.95. Is that clear?
Yes, sir.
And when I draw
Sir,
the
I have a
graph,
question.
yes.
Sir, in the syntax, like especially in this, like when we are trying to plot, we are using
Yes.
this like when we type equals to O. So what does that part do exactly?
Type, that means show the probabilities by 0, circle.
0. Okay.
0 नहीं है वो, O का small letter.
Okay.
It is representing on the graph. देखो graph पर है वो.
Sir, is it on the axis or is it those dots that we're replacing?
It is on the graph.
Okay.
देख लो ना graph पर.
Okay, so can we change that to something else?
That I don't know. I have to verify.
Okay, sir. Sure. Thank you.
So the intersection of the vertical line and the graph is my O. That is probability. Any other question for 2?
Sir,
Yes.
sir, for cumulative we apply P binom, right?
Yes.
So, on the above there is a cumulative PBD. Can you explain that once again?
cumulative probability for binomial distribution. That's all.
सर तो नीचे हमने पी बाइनॉम डाला है, ऊपर पीयू पीबीडी, तो ये अलग अलग सिंटेक्स यूज
That is variable. That is variable. Left hand side of the symbol is away. Anything you can use. Right hand side should be p binom.
Okay, thank you.
So we have come up to question number 2. Ayushi Rohatgi.
Yes, sir.
Do you follow today's work?
Yes, sir. I am following. Like
Yeah.
I'm trying to follow.
Okay. Pitanjal Datta.
Hi, sir. Yes, sir.
You joined today?
Yes, sir. I'm actually from agribusiness, but we've received this scheduled. Yes, sir. This is my second class.
Oh, so you have missed many of the classes?
Yes, sir. I'm catching up. Like I'm connecting with friends and catching up.
So you have to be up to date before the next class.
Yes, sir. So I'll try to be. Yes, sir.
Okay. So now we are going for another question, number 4. Yes. Suppose 4 students each have about an average 80% in the course so far. Assume this means probability of maintaining or improving their average is 0.8. What is the probability that all 4 will maintain or improve their average? Second part. If X is the number of students show improvement among a sample of 10 students, find the probability 3 to 7 inclusive, X greater than 8, 8 exclusive, X less than 9, 9 exclusive. This is the question I am going to do. This is the question that I am going to do. So the probability is given. You have probabilities are given. And the samples are of 4, and in the second part 10. So let us see how to do this. Y. I denote Y now for question number 3. Y is the number of students who has the average score 80% or they improve. 0, 1, 2, 3, 4. binomial distribution and the probability. Answer for all of them. Finished. This is first part. All of them.
Sir, I'm very sorry. I didn't understand the question.
Probability that a student get distinction is 0.8. You are having a sample of 4 students. Evaluate the probability that all of them got distinction. This is the question.
Oh, okay.
Clear?
Yes, sir.
Now I'm changing. Not 4 students. I'm selecting a class of 10 students. So the distribution, binomial probability distribution is given. Binomial probability distribution is given. And my AB line vertical will be Y1. Suppose if I want to draw the line, I say type in quotation see the graph, better graph. Show the vertical lines with color. I will get a beautiful graph to identify the probabilities. So the first probability Y, I stand for first answer, first question ka answer, PY1 is for 3, 4, 5, 6, 7. Three, 4, 5, 6, 7. Compute it and add up. Next. Greater than 8. That means 9 and 10. Lastly, less than that means 0 to 8. These are the 3 probabilities. This can be computed in another way. First one, P binom up to 7 minus P binom up to 2. Because P binom tells you cumulative probability starting from minimum to 7. P binom 2 stands for cumulative probability from minimum to 2. Total will be minus this will give you the answer. Greater than 8 means 1 minus less than or equal to 8. Less than 9 means up to 8. So using the P binom, you can compute the probability. Your answer still remains the same. See the answer, both the case it will remain the same. Both the case it remains the same.
Sir, I'm sorry, I did not get the difference between D binom and P binom. Could you please repeat that?
I think you are disconnecting your concentration. D stand for distribution. Distribution. Binom, that means individual values of X and the probability. That is distribution. See, for example, question number 3 once again. Don't lose the concentration when I explain. My Y will be 0, 1, 2, 3, 4. D binom. That means for every value, evaluate probability. See the answer. See the answer. How many probability you have? Come on. On the
5,
console,
sir, 5.
How many? 5. How many values Y has? How many values Y has? How many values Y has?
5.
5. Which are they?
5 values. 5 values.
Which are they?
0, 1, 2, 3, 4.
So 0, 0, 1, 6 is the probability for whom?
Zero.
Suppose 0.
0.0256 is the probability for whom?
1.
0.1536 is the probability for whom?
It's for 2, sir.
4096
Oh,
is
sorry,
the
sorry.
probability
For
for
3,
whom?
for 3, sir.
And 4096 is the probability for
4.
4. So D binom gives the individual probability. T binom will give you individual probability, whereas P binom will give you cumulative probability, P. P binom. For example, in question number 3 itself, I will compute once again. I denote cumulative P for Y. P binom Y probability will be, sample size will be 4 with probability 0.8. CUPY. Let me let me compute it. What is the probability 0.0016?
That is the probability of 1 for the first trial.
For y is equal to 0.
Correct.
0, sir.
0.0272 is the probability for
Y equal
0
to
to
0
1.
plus y equal to 1.
0.1808 is the probability for
0 plus 1 plus 2.
0.5904 is the probability for
0 plus 1 plus 2 plus 3.
and 1 is the probability for all. Now any question to anybody?
No, sir, it cleared perfectly.
It's clear, matlab you have to concentrate. I know you are student, so I am reducing the speed and explaining. You have to write and listen and make the class progress. And whether it is probability distribution or cumulative probabilities, you can plot. That already I have shown to you. Probability plotting also possible. Okay. So you know now the graph. You know how to find probability by two functions. You have the graph and you know how to find the probabilities. Two functions you have learned. Now, I'm going to explain a real life example. How to apply binomial distribution in real life problem. Okay. Attentive. This will give you an idea about in a real life. This is the only example for next 1 hour. Real life example. In which binomial distribution is used. One. This is an example for poultry farm. Anywhere you can use. 2. 1 egg tray can occupy 6 eggs. Sales manager states that, all of you attentive, 0.32
Yes, sir.
is the probability that an egg damages in road transportation. Four. 500 such trays are now transported to the distributed by road. 5. Find how many trays are having zero, 1, 2, 3, 4, 5, 6 eggs damage per tray. This is the research problem. Now, statistic. And what our statistic says, a tray has n equal to 6 eggs. Probability an egg damage equal to P equal to 0.32. X equal to 0, 1, 2, 3, 4, 5, 6. Thus, a single tray is binomial model with parameter n equal to 6, p equal to 0.32. This is statistics. Yes. Now I will give time for you to ask questions. A real research problem. To get the research output, I have converted that into statistical problem. Yes. You can ask question now. But after explanation, then don't ask the elementary question. So the red color is similar to our question 1, 2, 3. In the first, there are 6 customers. In the next, it has 5 drills. In the next, we have 4 students. And the last, we have 10 students. Here, egg, 6 eggs. There, P is given. Here also, P is given. Here, a tray means a sample of 6 eggs.
Sir?
Yes.
Sir, can you please explain the last line? That is, thus a single tray is equal to binomial model, that part.
Yes, that is what I say. One tray means 6 eggs.
Okay, sir.
So when it reaches to the distributor, usme all are good or all are bad or any number between 0 to 6 damaged.
Okay,
Sir, I have a question.
Yes.
Sir, isn't n equal to 500 into 6? Like total trays are 500.
Madam, what you are listening? Huh? 506 का English language देखो. Come on, read it. English sentence पढ़ो.
500 such trays are now transported.
सच मैंने यूज किया है. सच मतलब कितना ट्रेस? 500 ट्रेस. ट्रेस इज ए प्लूरल. टोटल कितना एग्स हो गया अभी बताइए? कम ऑन.
500 into 6.
That is 3000 eggs are shipped, but they are not shipped loose. They are packed as 6 each. Are you getting?
Okay.
English sentence देखो. Any other question? Ask. Once I start my statistical work, I will not entertain any elementary question. You have to have full concentration. Repeat. My one tray, one, single, plural नहीं है, single, is a similar to question number 1, 2, 3, 4 we did. In the first question, customers, 6 customers. A group of 6 customers. Here a group of 6 eggs. Their customer. Here egg. In the second question today, we have done 5 drills. Here 6 eggs.
Sorry.
In the third question, we have done 4 students, plural. Here 6 eggs. And the last 10 students. Here it is 6 eggs. In the first question, probability of preferring coffee, 0.3. Here, probability a egg damage is 0.32. Next question, probability, देख लो English, singular. A perfect drill is 0.95. So, probability here, an egg damage, 0.32. 0.8 is the probability a student maintained the grade. Here 0.32 is the probability an egg damaged. So I wrote here a tray is similar to that of earlier question. And all the earlier questions we have answered with binomial distribution. So the single tray is a binomial model for answering the research 5. Now, capital N equal to 500. Capital N is 500. Trace. So the objective is how many among 500 trays
English typing palace. क्या कर रहा है?
has X damaged egg. I will explain. Before I explain, who can help me to answer, or rather, meaning of my research problem? Objective is how many among 500 trays has X damaged the egg? Who can explain me that?
Sir, it means that out of the 500 trays which are being transported, how many trays have 0 to 6 damages? That means either
Correct.
0, 1, 2,
Perfect.
3, 4, or 6 damaged eggs.
So in that we say classify the trays according to X. Answer equal to classify the shipment according to X. That means frequency distribution of 500 trays according to X. Any other question? Who explained me just now? Who is he? Name please.
So Setu.
Very good. Very good. Now question. I'm giving time. No more example today, only this example. I already said research is the main objective in statistical analysis. Wherever the decision is uncertain, you are analyzing sample. And to reach a better result, computation as well as probabilities is a must. So I have introduced probability binomial distribution. Today I never said coin, die, marble, playing cards, nothing. So the poultry farm manager asked the statistician how to classify 500 trays with respect to damaged. You will see at the end how research and statistics helps to improve business. Shall I continue?
Yes, sir.
Okay. So I am repeating now our earlier computational work in this example first. This type of example manually doing is very difficult. So now I will be talking about my work. This is my research problem. A poultry farm manager states that an egg damage in the distribution is 0.32. A tray has 6 eggs. "500 such trays are transported. A research topic is classify them with W instead of X because X already I have used. Number of eggs damaged per tray." So here my success means damaged egg. And not damaged will be 0.68. An egg, single, each. And the tray is a binomial model. So, somebody should explain me this output. Tell me, what are these probabilities? I have used D binom.
So there are probabilities of egg being damaged, zero egg being damaged, one egg being damaged, two eggs being damaged, till 6 eggs being damaged.
In
a tray, sir.
A tray. Very good. Very good.
It would be beneficial if we multiply these numbers by 500. So it will give us a good example of in 500 trays how many might get damaged.
Yes. Because this probability distribution is same for every 500, isn't it?
Yes, sir.
This probability distribution that remains the same for each and every tray among 500. Attentive, this is a research problem. So I multiply them and get it. Tell me, what is that approximately 49? Come on.
So it is the number.
That means
These many.
In out of 500 trays, expected 49.4 trays
each having zero damage, correct?
Zero damages, yes.
Very good. 139.577.
One damage.
Each one.
Each tray having
Each of the 139.577 trays have one damage.
Exactly one damage.
Yes. So this is what the count. Did he allow to open the 500 and check again? No. Will he allow?
No, sir.
No. So without opening the packing of 500 trays, with past business data for P.32, if 500 trays are reached to the distributor, these many are having possible damaged trays, correct now?
Yes, sir.
Will the distributor complain to the sales manager?
any sales manager, any customer would want minimal damage.
Poultry farm has shipped it to the distributor. He got the money for 500 trays, but roads are not good. So by road transportation, this is possible to happen. So when I show this number to the distributor, will he complain to the manager and ask money back?
Yes, sir, because any distributor would want complete eggs.
Yes. He doesn't want such a number in the shipment, correct now? Yes,
sir,
or
he
no?
would want 500. Yes, sir, he would want complete.
He want minimum. He knows by transportation there may be possibility of damage, but that number has to be minimum, correct now? How to do that?
So sir, distributor should send more eggs, like taking into account what the damage might be, so that the minimum number of eggs which are not damaged should be 500. So it would be 500 plus all these, the probabilities.
What is to be done now? What is to be done?
Try to figure out how to increase reduce the probability of a egg.
Very good. Very good. Who is it?
Neil.
Yes. So this is the graph output by the researcher. So if I want to have the peak much more to the left, I have to concentrate on transportation, correct now?
Yes, sir.
Yes, sir.
So I told the sales manager, which is your route for transportation? Okay. Then he said, this is in Pimpri. So he says from Pimpri to Shivaji Nagar to Deccan Gymkhana to Kothrood. Plenty speed breakers. Transportation by road definitely make disturbance to the packing system. So I told him, instead of cardboard trays, because you might have seen in the shop, eggs are purchased in trays of cardboard type. Little plastic type tray you make, and instead of taking this route, Pimpri to Chandri Chowk by Bangalore Bombay highway, come down to Kothrood, because on highway speed breakers are nil, gutters are less, smooth riding. Only that plastic tray expensive to make. But I told him, once you make, after removing the egg, you take back the tray from the distributor. He tried one time. Attentive. He tried one time and the probability was 0.22. See the graph now. See my complete answer now with 0.22. Where the graph moved?
Towards left.
Left, right.
So now, smaller the probability, distributor will complain. How many of you follow? Is it the graph clear?
Yes, sir.
Yes.
So he was so happy. So he used such a plastic molded trays and the route different. Further, he got the probability 0.12. See the graph now. Will there be loss to the sales manager with probability 0.12?
No, sir.
So the loss will be
Not at all.
minimal. Minimal. Very
Yes,
minimal
loss is minimum. He doesn't know statistics. But external factors disturbs the output. So why this disturbance happening, statistician should know. Develop strategies to improve the performance. This is what we demonstrate. One week it took to me to do this work to the person, but he gave me a very good fee. Because he doesn't know statistics and why this is happening. So, we studied coin, die, playing card. All those are classroom examples. All those are classroom examples. Actually, a statistician should know how to convert the real problem into statistical problem. Sir, the tray is charged, the tray manufacturer charges me more. I told him, per egg you increase 50 paise. And egg will be used every time. So your profit will be much better than the cardboard tray. Your plastic tray business for egg much better than that of cardboard. Amit Ingale. Amit.
Yes, sir.
Do you
Yes,
follow
sir.
the real work?
Yes, sir.
Sure.
Yes.
Okay. Anuj Srivastava. Anuj Srivastava.
Yes, sir.
Do you follow the real work?
Yes, sir.
Okay. Bhanu Sharma.
Yes, sir.
Do you follow the today's work?
Yes, sir. I'm trying.
Not
follow.
trying.
This is
You
my
have to understand.
Yes, sir.
Okay. Mohit Mishra.
Yes, sir.
Clear the work?
Yes, sir.
Sure?
Yes, sir.
Okay. Neeldhar.
Yes, sir.
Do you follow the real work?
Yes, sir. Yeah.
Clear now?
Yeah. A lot more after doing it.
Yes, please.
Sir, clear, sir.
So today, now it is already 4 o'clock. I have done nothing other than only one distribution, binomial distribution. binomial distribution. In this binomial distribution, I have taken the tray example. So in this tray example, single tray is a binomial experiment. 500 trays are same repeated binomial experiment. Another way I explain. A single tray is a binomial experiment. And repeated 500 trays are binomial experiment repeated independently. So when you have huge bulk of data, decision making very difficult other than statistical analysis. That is what I have shown. Very difficult. Packed box of trays are open a check. But of course, prior information is available. As a poultry farm businessman, he knows what is happening in the past. He wants to improve the business. So he asked the statistician, so they asked statistician, why COVID vaccine will be given first priority to all the warriors of the pandemic? Tell me. Why COVID vaccine will be given first to them?
Sir, because they have high probability of catching the disease.
They are the one doing the work for the globe. Second stage will be for elders after age 50 and complicated cases of the individual. Who is the one getting last?
Between 16 to 50 age group.
Yes. So it is not random work. It is not at all random. But study the phenomena throughout the global level, country-wise, state-wise. Unique decision. Every information we are getting is in number form. Every information that we are reading, we are getting, all are in number form. Either in percentages, it may be by graph, it may be by chart, it may be by table. So, decision-making point of view, one has to put lot of effort. You are new. Research is not a joke. If you want to survive in the area of research, and if you have an ambition, you have to know number games. You have to know the number games. You will see now on Thursday what is happening. On Thursday, we are going higher level of binomial distribution. And this binomial distribution is a discrete distribution. This binomial distribution is a discrete distribution because the characteristic is countably finite values. Any example you take, it cannot be decimal. Probability is decimal, but the real values are not decimal. But height of the student is not discrete. Rainfall per day is not discrete. Temperature per day is not discrete. Then what to do? There, binomial distribution is not possible. So we have to learn new models. That is the reason I told in the very beginning. Statistical tools are having its own assumptions. Depends on your research area, you have to choose the tool. Depends on the area of research, area of survey. You have to choose the statistical tools. Now see, first we were computing mean, variance, standard deviation, correlation, regression. Those all are computational work in the sample. But how good are they? Probabilities you have to know. Wait now, after certain session, last sessions are testing of hypothesis. The one who understands probability, he will be able to answer questions at that time. So be careful. Don't simply listen and copy. Think on it. Think on it. Yes. Now it is the time to close, but before that, initially there were about 90 students, now only 78. They know as the classes progresses, sir will ask questions, so they will disconnect. Anyhow, let us see. Today now at the screen 78, I am asking questions.
Sir, I had a question.
Yes.
So the question number 3 that we did today, can you go back to the console once?
So let me close the graph. You want the graph also?
No, sir. So question number 3, not this one. Okay. The one before this.
Okay. You want the console or editor?
Just the console. So a little more down. Could you just scroll a little down? Yes, sir, that's all.
Okay.
So, sir, here when we are doing PYA, P binom. So, sir, here, could you just explain this to me?
Yes.
In the first one, it says x equal to greater than 3 and less than equal to 7. So, here we put 7, 10, 0.8. minus P binom for 2, 10, 0.8.
Yeah.
So, sir, could you just explain these three to me, like PYA, PYB, PYC ones?
Yes. What is the first interval? 3 to?
So, 3 to 7 inclusive 3 and 7.
So P binom 7 gives you the addition of probability up to 7. Okay?
Yes, sir.
Minus addition of probability up to 2 will give you between 3 to 7.
Okay, sir. So the next one?
Total probability is 1.
Yes, sir.
From that, you subtract the probability up to 8, you will get above 8.
Understood. Okay.
Same way for the last. See, your answer also still remains the same.
Okay, sir. Understood. Thank you so much. There was just a little confusion. Thank you.
So therefore, the work today we have done was nothing other than binomial distribution. Let me see. Some numbers I never called. Who are they? Let me see. Ruma Keshri. Ruma Keshri. Yeah, you joined late?
No, sir.
Okay, you attended all the sessions?
Yes, sir.
You followed today's real application?
Yes, sir.
Good. Tanuja Phad?
Yes, sir.
Do you follow today's classification data?
Yes, sir. Yes, sir. I followed.
Okay. Now, any question from your side?
Sir, I have a doubt regarding the assignment.
Yes.
Sir, in question 2, when we see the table, first 4 columns are below 0, below 10, below 20, and so on. And the last one is above 50. So I don't know. I mean, I discussed it with one of my friends and I'm not able to deal with that.
Draw a line and put the numbers and check. What do you meaning? Otherwise, I will explain you on Thursday.
Okay, sir. So because I tried and it was giving some error on
the assignment is for you to think and work. Good that you are doing by yourself and copying from someone. Good.
Okay, sir.
Thursday
If I'm not able to do, I'll ask on Thursday again.
Thursday you have to ask again.
Okay, sir. I'll ask. Thank you.
Next. Next, anybody has any question?
So can you please show us the syntax of all the questions so that we can take pictures of it? Because we were going a little bit fast, I guess.
Yeah. Syntax is given in your module, Ray.
Okay, sir. Okay. Thank you.
It is there in module. You can check. In the handout, I have given highlighted. Dekh lo. Our syntax are these many, of which I explained only 2. 3 and 4 is Thursday.
Okay, sir. Thank you.
Okay, any other question? Any other question?
Yes, sir. Sir, in question number 3, where we have to make a matrix.
Yes.
So in our answer sheet, do we have to show that matrix as well, or just the algorithm?
No. Matrix बहुत बड़ा होगा वो. Not necessary.
Okay.
Output should be in matrix form.
Sir, so we have to show the output in the matrix form in the
Yes,
our answer sheet.
arithmetic mean variance and standard deviation and CV.
Okay, sir. Okay.
Yes, Ayushi.
Yes, sir. You answered my question.
Yeah.
Okay. Thank you.
Anyone else? Good. Class is doing very well. Let us hope we will do a better work in future. Okay. Have a good day. Thank you.
Thank you, sir.
Thank you, sir.
Bye, sir.